So now we'll be doing our next example, sorted insert. So given a sorted list like this one, we want to be able to insert a new node with a different value or the same value so that it keeps its same order, it stays in order. So say for example we were given this list and a number 5. We want to be able to insert it so that we have this list with our 5 inserted between 3 and 8 so that the final list is in order. Our function signature would look like this. Our parameters being the list itself and just the number, like 5 for example. So we'll have to create our own node and then put our value into the node and then insert the node. Now there's lots of cases to consider with this example, with this, this function, which we'll get to as we go along. So let's deal with the most generic case. If we want to insert our node somewhere in the middle of our list, so 5 is a good example because it will fit between 3 and 8. So what we'll have to do is first we'll have to create a current pointer, which points to the first node. Then what we'll have to do is we'll have to get it to iterate continuously until it gets to the node before the position we wish to insert our new element into. Now that's a bit wordy. It means like, say for example we want to put this node here between 3 and 8. So what we'll have to do is we'll have to stop at 3 because that is the node before the position we want to insert our new node into. So in this case we'll just have to call current, or execute current equals current next once. But if there were lots of nodes before here, we'd have to use a loop to get to the right position. So once we're at the node before our insertion spot, what we'll do is, if we recall from previous videos, we can't straight away set this to point to our new node, and then our new node to point to the last node, because then we'll lose our old node, because this pointer will get lost. So what we'll do instead is we'll stop this from being null, and we'll instead set it to current next, which is this node over here. And then what we'll do is, so this is pointing here. Well, so what we'll do is we'll now switch it so that this one points to our new node, like this over here. We can do that by saying current next equals new, because this is new, as we see over here. Okay, cool. We have to remember that we need to malloc this node. It will not be malloced for us, or declared on the stack. Now, once we've done this, we should end up with a list like this, and that's what we wanted. But there's a few cases that we have to deal with. Say, for example, we wanted to insert an element right at the beginning. Now, in order to get current to point to the node before our insertion spot, what we have to do is say, while current, well, I'll leave the coding to Callum, but essentially, if we need current to initially point to the first node. So over here, we set it equal to the address of the first node. Now, if we want to put an element at the beginning of the list, so for example, if we wanted to insert 0, that would go here, and our current is already pointing to the node after that insertion spot. But if we recall from here, we need it to point to the node before the insertion spot. So that means what we need to do is make a special case for this, because we cannot do it like this. So what we'll do is we'll just call our prepend function. We'll call our prepend function, which will insert our element right at the beginning of the list. So we've already written that. We can either call the function if it's already been written, or we can just write it. It's either 1 or 2 lines, depending on how you code it. And that'll deal with that case for us. That'll work for, that will also work if we have no elements in our list. So say, for example, if we have a list that is empty, so we could call prepend, because when we wrote prepend, we dealt with the empty list case as, well, we just want to return our new node. We'll create a new node, set it the value, make sure its pointer is null, and then we'll just return that new node. So that strategy will work as well. So yeah, that sums it up for sorted insert.